a multi-tier application architecture for our customer-facing services, but then they were tightly coupled and functioned from a development, a deployment, and management perspective in a monolithic way. Then as time's gone on, we've evolved to service-oriented architectures. And this is where the monolith was broken down into major components, but still had functions or subcomponents as part of it. There may have been multiple tiers to it, such as logic tiers, application tiers, and other front-end facing tiers, and then at the back-end data tiers. So the move to service-oriented architecture goes back a number of years now, and we're seeing that now there's thousands of applications that leverage a service-oriented architecture. And now the next evolution that we're seeing is a microservices architecture, where we take this service-oriented architecture and split them down even further, decouple them even more, so that, as you can see in this diagram, you've got these various, really loosely coupled elements within your infrastructure, which provide a more discrete form of management, control, etc. So there are, over time, we've seen with especially service-oriented architecture, a number of tools that have come to help customers, such as web servers, code libraries, continuous integration, continuous deployment patterns, containers, API management, configuration management tools, etc. And a large number of tools are available to you to help with this service-oriented, this evolution of or move to service-oriented architecture. We've also, along the way, been helping with it too, with services such as Elastic Compute, our on-demand compute service, auto-scaling, load balancers, other services like Elastic Beanstalk, our Trusted Advisor service. These are all tools which help as part of this service-oriented approach. But there's still, all of these tools and innovations are still coupled to a shared dependency. So although we've been able to break down, the monolithic to service-oriented architecture to more discrete components, there is still a coupling to a shared dependency, and that of course is service. And there's some examples on the screen that you can see now is such as what are the decisions we need to make as part of using servers to stand up various applications, such as what size servers do I need, how do I control access, how do I handle change management, how do I scale, which operating system. There's all these questions are still there as part of even with a service-oriented architecture or a move to microservices. You still got these dilemmas and challenges to plan how you're going to provide that service or that application to your customers. So we've made, as collectively we've made it's been a great journey, but we still have this huge dilemma of servers, managing it, provisioning them, deploying them, etc. So this has kind of led to an evolution of our customers coming to us and moving towards, how do we remove servers from this? And I'm just going to step back again and look at it from a different perspective of why we think serverless is an important kind of shift in the way our customers are designing and deploying applications on AWS. So if you just look at, say, on the AWS cloud, and we have this diagram where there's our complete infrastructure, and inside that is a collection of instances. And they may be providing a particular application or pools of functionality. They could be an individual server. They could be a scaling group of servers. And on each one of those instances, we're running application code. So this is the situation, a couple of years ago. You'd have AWS infrastructure. Inside that, you'd have pools and groups of servers, instances, and running on them would be application code. And that application code would provide different functionality. It would work with data. It may be stored in a database. It may be stored in object storage. But then, next, we moved to containers. Containers came out a couple of years ago and allowed us to work with those same instances and leverage and utilize that capacity even more so. So containers run inside our instances, our virtual servers. They still use the same pool of instances. They still use the same AWS infrastructure. And inside them, we're running application code. So we started with servers and application code running on inside instances. And we've now got container service on Amazon, which is fantastic. Containers, those applications are still doing the same function. They're still working with data. They're still using, integrating with third-party services or additional services on AWS. So what if we took away the servers, the need for servers? You see, all we really care about is the application code. All we care about is the data it's working with and the other bits of application code that it works with in the other services. Those servers and even those containers that we saw in the previous diagrams, they don't really matter. They don't necessarily add value to the application we want to provide to our customers. So this is the shift. This is the shift. How do we take away all those management, operational, decision-making points that we have with the servers themselves, whether that's the networks, the scanning groups, the capacity. And this is the key value that we're seeing with serverless. How do we just focus on the application code, the data it needs to work with, and then the other bits of application code it needs to talk to and other services, etc. So that's what I'm talking about in this webinar today, that shift from being able to totally not worry about what is the underlying infrastructure that provides that application code to execute. So kind of key points about architecting these serverless. What are we really talking about? So serverless, we're talking about fully managed, no provisioning, zero administration, high availability. So if we have a function of code, we don't want to be worrying about where's it going to run, how's it going to run, how are we going to get it there. Just fully automatic. We have a piece, a function of application code, and it's just going to, through the AWS platform, be executed when it's needed, how it's needed. And in terms of developer productivity, focusing on just the code that matters. And that way we can innovate more rapidly, our customers can innovate more rapidly, and as soon as we write that function or a new version of it, we can very, very quickly get it into production so that customers can leverage it. And the other big feature is continuously scaling, so automatically scaling up and down. The infrastructure is dynamic. The application code can run once or it can run 1,000,000 times. Not having to worry about thinking about all the challenges we've had to with compute or even containers and worrying about plumbing in and scaling that environment to cope with dynamic demand. So the first service as part of a serverless architecture is Amazon Lambda, AWS Lambda. Lambda is a fully managed event-driven compute service. It's a microservice without servers. That's how we tend to think of Lambda. Fully serverless, we write a function, upload it to the Lambda service, and then you can enable it to be executed in a number of different ways as needed. So some benefits to AWS Lambda. First of all, serverless. We don't have the concept of servers with Lambda. We write a function, and it can be executed any number of times across the Lambda infrastructure. We don't have to worry about any of the underlying infrastructure. Next is event-driven scale. And this is kind of a key difference with serverless as opposed to, say, platform as a service. Event-driven integration, where external events across the AWS platform can cause these functions, these Lambda functions, to be executed. And the third one, the big one, when we're only worrying about the application code that's running, these functions, we can then start thinking about billing in much smaller increments. In which case, with Lambda, we can think about 100 millisecond increments. So we're just worrying about how much to charge based on the time it takes to execute that function. And that's a massive difference from traditional compute, where you're worrying about how much it costs each server to run each hour. So some more capabilities. With Lambda, you can bring your own code, and that's Node.js, Java, or Python. There's a really simple resource model for Lambda. All we need to do is define for each particular function how much memory it needs to run. And automatically, behind the scenes, we'll scale the compute power it's given to match that amount of memory. Next is invocation paths. You can use events to kick off Lambda functions, or you can use a scheduling or time-based approach to invoke functions. Finally, really granular permissions control. Integration with AWS Identity and Access Management, you have fine-grained control over your Lambda functions, how they run, where they run, etc. So Lambda, how does it work? We author a function in the particular language of choice, and we upload it into the Lambda service. Our functions are designed to be stateless. So think of Lambda functions as being little bubbles that execute and do something really, really well, and then as soon as the execution's done, they disappear. There's no concept of worrying about the server that it runs on or the infrastructure. All we've got to do is think about that little function, discrete, finely focused function. It'll execute, and then once the execution's finished, it'll just disappear, and everything needed to run it will disappear as well. So truly stateless. It's important we think of functions in Lambda as being truly stateless. Next, of course, is deployment. You write a function, put it into the Lambda service, and everything else is taken care of. When it needs to be run, Lambda will make sure it's there and ready to go as it's being invoked. Finally, monitoring and logging. Fully integrated monitoring and logging in the Lambda service allows you to see how many times your functions run and a number of other metrics and give you logs around them. So that allows you to both debug and also look at the use of your service, how much has been utilized, whether you've got it, the right amount of resource for that function assigned, etc. And we also have partner ecosystem. And we've got a number of partners that are working with us to make Lambda a much more richer and capable service. So some components of Lambda. So we write a function, or you write a function in the Lambda service. You can choose an event source that causes that function to run, and you have a networking environment behind it. Everything else as part of the Lambda service is fully managed and taken care of by AWS. So I'll step through some of these in more detail now. So the function can be your code written in either Java, Node.js, JavaScript, or Python. And I've got an example here of a Lambda function on the right-hand side written in JavaScript. You assign an IAM role that the code assumes during execution. So IAM, of course, is Amazon Web Services Identity and Access Management. And we assign the amount of memory allocated to your code, which starts at 128 megabytes and goes up to 1.5 gig. Now, of course, the larger amount of RAM or memory that's allocated, then the more cost that function costs to be invoked. So we want to have it as lean as possible, or as cost optimized as possible for each invocation. So you're not wasting valuable money. So really, see three simple parts to a Lambda function: the code you write, the role it's going to execute with, and the amount of memory it needs for that code to execute, which of course in turn affects the amount of CPU and network which is scaled behind the scenes for that function. So event sources. So these are the things on the AWS platform that can cause Lambda functions to be run. And this is a real big shift from where we may have seen, like in the past, say, platform as a service. With event sources, this is where we can have different services across AWS causing a Lambda function to run. So for example, with Amazon S3 Simple Storage Service, if you put an object or store a new object in S3, then an event is created, and that event can cause a Lambda function to run. Or Amazon DynamoDB, our NoSQL database service, if you add a new record to a table in DynamoDB, then that also creates an event, and you could have a Lambda function run based on a new record being added to a database. Or a notification, or Amazon Kinesis, as streams come in. As new data comes in on a stream, you can cause Lambda functions to be run. So these are event sources where a number of services across the AWS platform can cause Lambda functions to run. And this becomes incredibly powerful. So Lambda runs your function code without you managing or scaling services. We provide an API so that you can also trigger the execution of your function. So we have event sources which can automatically create the invocation of a function. We also have an API where you could manually get your function Also, we have support for networking with Lambda. So by default, Lambda works outside of the context of your virtual private cloud, your VPC, your isolated private part of AWS platform. But we also support customer VPCs. So now you can have your Lambda functions run entirely within your AWS environment. So you get to choose whether you want the default of just a default network environment within a VPC provider for you, or within your own specific customer VPC. So you may be thinking, well, hold on, how does this change? How is this unique? And I've kind of alluded to it so far. So previously, there is lots of ways, or existingly, there is lots of ways to abstract away your services. Software as a service, platform as a service, database services, also, back office or backend as a service, but they are fundamentally different. Where serverless is much more powerful and capable is those integrations across the platform, across the AWS platform, that event-driven approach. These services, software as a service, platform as a service specifically, were isolated individual services. Serverless, with Lambda, utilizing Lambda and other services, takes it to and integrates across the AWS platform. So what's unique about Lambda? So abstraction at the code function level. It's arbitrary, flexible, and familiar. In other words, you're writing code like you've always written it, whether it's Node.js, Java, or Python. The security model is also incredibly familiar. So you're utilizing identity and access management, VPC, natively within Lambda. The pricing model is based on the number of invocations. There's now a really rich community being built up around Lambda. We're seeing it with partners that are providing tools for Lambda, but we're also seeing it online with, say, our forums, where we're seeing customers sharing information, sharing ideas on how to utilize Lambda to achieve things either more effectively or faster. And of course, integration across the AWS service ecosystem. So that's triggers, events, etc. Those are really big and unique aspects of Lambda. So let me just give you an example. This is just a quick kind of snapshot of the difference of doing things with Lambda versus how we would have done them historically. So here's on screen now is an example of a data processing architecture with servers. There's a number of different things going on in this diagram. You can see there's nodes on the right-hand side, worker nodes. We have a source of data off on the left. We have servers which are pushing data, listening to the source, and then pushing it to different queues. And then we have the fleet of servers on the right taking action based on that. But there's a lot of configuration and management there. In order to stand up this architecture, you've got to worry about a number of services, such as EC2 for your compute, your network, the polling of the servers, the polling of the source of data, writing, not only just writing the code to what it does to, say, push data to a queue, but also the complete application there of how it functions, etc. And then, of course, there's the management of it. There's things like managing cross-availability zone replication and making sure it's highly available, highly resilient. So if we look at this same architecture, simple architecture of listening to a source of data and then pushing that data onto a queue and taking action on it, how does it look like with Lambda? So with Lambda, much more straightforward. We have a source of data. The source of data can be attached through an event to the invocation of a Lambda function, and then every time that source of data comes in, that Lambda function is run. You don't have to worry about polling the source of data with some sort of middle tier application. You don't have to worry about queuing. You don't have to worry about auto-scaling. You don't have to worry about cross-availability zone, replication or redundancy. Lambda just takes care of all of it. We just write a function once. We determine a way in which that function will be invocated or executed, such as an event, and then everything else is managed behind the scenes. It's a massive simplification of what we need to do to have our outcome for that particular function. So, but there's also other serverless options on AWS, and it's important to think not just in terms of Lambda and that function, that code running, But there's other aspects of serverless too which kind of make this capability and make it special, such as our database service, network messaging, logging. These are all fully managed services. So we don't need to worry about standing up the infrastructure behind them, worrying about managing them, maintaining them, patching them. These fully managed services make serverless possible in addition to Lambda and other services such as API Gateway. There is a bigger picture here. Lambda on its own isn't necessarily just serverless. You do need the benefits these other services are bringing, such as, say, user management, where you've got fully integrated identity and access management with the Lambda service. So leveraging these other services are also a part of serverless as well. It's not just about Lambda or a single service. Serverless does combine all those rich benefits across the AWS platform. So we've built up a capability that's allowed serverless to occur. So just a few examples of some more triggers for AWS Lambda. So such as AWS IoT actions occurring on our Internet of Things service, they can cause Lambda functions to be executed. How about also Cognito? Cognito, so when data is synced with the Cognito sync service from, say, a mobile device to Cognito, that can also cause an event which makes a Lambda function occur. Next, of course, is another example is CloudFormation. You can have custom resources on CloudFormation cause Lambda functions to be executed, and even Amazon Echo Skills on the Amazon Echo device, that can cause Lambda functions to be executed. So just a few more ideas there of what can cause cause Lambda functions to be executed. And one more thing worth mentioning, of course, you can also do schedule events on Lambda. In other words, you can set a time for a function to be executed. So I'm going to just step through some example serverless architectures. I'm not going to dig too deep. These are really just to kind of share some ideas of how serverless can be used. And the first is real-time stream processing using Kinesis and Lambda. And of course, Kinesis is our streaming service. So Kinesis can consume streams of data from external services or even internally. So Kinesis may have a stream of data coming in, and then each time we have data coming in, that can cause an event for a Lambda function to run, and then the Lambda function may be able to analyze that data coming in, or modify it, transform it, and can put it into, say, Redshift, our data warehouse service, or cause a notification. Maybe we want a mobile notification to go out that a particular data or type of data has come in. So real-time stream processing using Lambda, really simple to do, really easy to create an event connection between Kinesis and Lambda so that Lambda is executing a function based on data being streamed in real time. So that's the first example. Next is real-time database triggers workflow using DynamoDB, our NoSQL database service, and AWS Lambda. So this DynamoDB can have data come in, so let's say we add a new record or modify a record in a table, and then with each of those events in the database, a Lambda function can be executed. And maybe it's to create an index. Let's just say, for example, we've got a table of customer data, and we want to have an index that's maintained, a separate index of some particular function. Maybe we're modifying it or transforming it. And so we use Lambda to create that. Maybe it's even in a different Amazon DynamoDB table, or even in a different region. Some people would call this poor man's replication, where data comes in DynamoDB, we add a record, Lambda function runs, and goes and stores that record somewhere else, maybe in another Amazon DynamoDB table elsewhere. Or it's maybe putting it into Amazon Redshift. So it's really quite capable and rich to asynchronously do functions based on the database of events occurring. Next one, so real-time message handling workflow using Amazon SNS and AWS Lambda. So SNS is our notification service, and for example, say a new message is published to the notification service. Well, that also creates an event, and Lambda can run a function based on that new notification. And maybe we want to have another notification occur, or maybe we want to cause some sort of event or action to occur on Amazon Kinesis, our streaming service. Maybe we want to stream to stop. Maybe a notification comes in and says there's a particular event or external factor that means we want to stop the streaming of data inbound. So functions, Lambda functions can run based on a notification service. Next one is a backend workflow using Amazon API Gateway, our fully managed RESTful API service, and AWS Lambda. So in this particular case, API Gateway has a RESTful interface, and an API is called, which in turn calls a Lambda function, and that Lambda function may go and modify or check on a new object that was, say, stored in S3, or maybe going to create an object in S3, or maybe it's going to add a record to a table in DynamoDB. So a RESTful interface, a RESTful API, causing Lambda functions to run. And again, this is a really rich scenario. We also have a more detailed example here of Lambda being used, and this is Play On Sports, which is a customer running in production on AWS using Lambda in a totally serverless way. And let me talk you through this example. So Play On Sports allows the streaming of sports to come in and be stored inside the object storage service, and then also to be consumed across mobile devices. So in this example here, we see sports being streamed in, and it comes in via CloudFront and gets stored into S3, our object storage service. But it will come in potentially a large, very rich format, high-resolution format. And that may not be optimal for streaming to the end customer devices, such as mobiles or tablets, etc. So we wanted the customer Play On Sports, wants to transcode those large original media files into smaller, more discrete, more optimized files that customers are going to consume. So as the media is streamed in and stored on S3, this causes an event for a number of different functions to run. And there's you can see in the center of the screen there is a master function, a number of cascaded, or more purposeful functions that go and transcode to different formats. So we may have a full high-def stream coming in, and then the Lambda function will get executed as it's streamed and stored in S3, and then we'll transcode it to, a function will transcode it, say, to 480p, to 360p, to thumbnail size, or to audio only. And then we'll store that in the S3 bucket that's used for playback. So incredibly scalable, no servers used in the entire service for this functionality, and yet it's entirely on demand. So as these streams come in and are stored in S3, they get automatically transcoded because the events are causing Lambda functions to be executed. Again, a really rich scenario, really powerful scenario. Okay, so that kind of leads to the question, so to really utilize Lambda, do you need to re-architect for an event-driven environment? Well, I think there's no doubt that you'll get most benefit by re-architecting applications for Lambda and API Gateway, which I'm about to talk about. You get the benefit of being able to utilize an event-driven, function-based approach to your code, and yes, you'll need to re-architect if you want to get the most benefits out of it. So let me talk now about API Gateway. So API Gateway is our RESTful, fully managed service for your APIs. It allows you to create APIs on the API Gateway service, configure and publish them, and also provide those other benefits of a fully managed service where it's fully monitored, it's integrated with our identity and access management and other platform security controls, and easy to maintain. So an automatically fully managed service that scales as your APIs are called. So this becomes a RESTful interface or RESTful front end for Lambda. Lambda itself, of course, is not, it doesn't have a REST interface. You can't call it from, say, a web page or a web server directly. You need to provide an API for it. An API Gateway provides that front end. So just some tips and tricks talking about using Lambda. So the first one is using Lambda to audit CloudTrail activity. So really good example here. CloudTrail is our service that keeps track and stores in Amazon S3 all the activity that goes on in your account. So that may be through APIs, it may be through the console, the main web console. Everything you do is stored by CloudTrail in files in Amazon S3. So as those logs are stored in S3, it creates an event, and you can assign a Lambda function to those events so that each time you get a CloudTrail activity, i.e. activity across your account, you can either send a notification, as an example, send a notification, or maybe you want that function to go and analyze IAM to make sure things are how they're meant to be, etc. So using Lambda to audit CloudTrail activity and make sure things that aren't expected aren't happening in your environment. You can use Lambda for automated infrastructure management. So for example, if you have a CloudWatch alarm, CloudWatch is our monitoring service, and you can have notifications that occur as a result of alarms. And those notifications can, of course, cause Lambda functions to run. Maybe you have an alarm that comes that notifies of a server, an EC2 instance, having some sort of fault or needing management. Maybe it's just filling up, etc. So you could cause a Lambda function to go and take action based on it. And you could do it across a number of services, such as EC2, our compute service, Elastic Compute, container service, Beanstalk, Kinesis, etc. So you can use CloudWatch alarms and notifications to get Lambda to take care of and automate the management of your infrastructure. Next example is using Lambda to forward AWS events to external endpoints. So if we have also CloudWatch events coming in or creating activities, so something causes a CloudWatch event or alarm, notification, Amazon notification service then causes a Lambda function. We could then talk to an external outside service such as if this then that, and cause external activities to happen. You know, a really simple example, of course, is if a server dies or there's some sort of fault with a server or group of servers or some service on your AWS infrastructure, you could have a light that comes on in your operations center. So the Lambda function could talk to if this then that, and then have a light that comes on or some sort of, you know, external maybe alarm or physical environment. So it's another interesting scenario of integrating with outside the AWS environment based on activities happening on your infrastructure. Next, of course, is using Lambda to deploy Lambda functions. So as you create and manage your Lambda code, it's likely you may store them in a GitHub repository. And GitHub, of course, can talk to Amazon SNS and cause notifications when new functions or new code is added to your repository. So in turn, that can cause a Lambda function to run, which may then go and take that new version of code to be uploaded into the Lambda service. So in other words, you've got Lambda running Lambda, or Lambda creating Lambda functions. Another rich scenario for, for version control and management and how your developers will work in a more complex environment where you have a number of people working on your Lambda functions. So GitHub being used as your repository, notifications being kicked off when you have new code submitted to the repository, and then a Lambda function running to upload that and insert it into create a Lambda function on AWS. A few other tips and tricks for extending Lambda functionality, and that's to use /temp space as cache when running your function. Make use of Grunt and Jenkins plugins. You can hook up Lambda functions to Slack, where you've got Lambda functions running based on conversations going on a Slack channel. And there's also another one worth looking at is JAWS. It's a serverless application framework that a third party, a customer has provided that allows you to manage your Lambda functions and help with the management of them. So some things to look at. So now I'm going to just quickly step through a web tier. I'm going to, in fact, I might just come back to this in a second. Let me just talk through a few more serverless architecture patterns. In other words, first, of course, is microservices. So we talk about microservices quite a bit with Lambda and API Gateway, and you get asked often, what's the connection? Is our microservices still relevant with Lambda? Well, the great thing about Lambda and serverless architectures is that they lead and they help towards microservices architecture. They lead themselves to it. There is a lot of similarities or architectural similarities or connections between small discrete functions or code, such as you write with Lambda, where it's a very small discrete function that runs based on either external events or schedule. And that naturally leads to what is a microservices architecture. So it helps write discrete functions, discrete loosely coupled functions. Mobile backend. Here's another example, mobile backend for a social media app, where a user is going to post data. API Gateway, which I talked about before, is our fully managed RESTful gateway service. So a mobile application talking to API Gateway, making a call, a Lambda function is triggered, which in turn creates a notification. Real-time analytics engine, in which case we're using our Kinesis, our fully managed distributed streaming service. As data is streamed in Kinesis, Lambda functions are triggered, which in turn may cause things like an index being created or data being stored in a DynamoDB database based on that data being streamed in. And then analysis of it using, say, a visualization tool, etc. Some serverless best practices. So let me just talk about some best practices with using Lambda. First of all is to limit your function size, especially with Java, as starting the JVM takes time. I think most people would understand that. It's much larger startup time with a JVM as opposed to, say, Python or Node.js. So really limit your function size. Keep it really discrete. Keep it single purpose. The intent with Lambda functions is to go and put 20 different outcomes or intents inside that function. Keep it to a single purpose, and then it executes, starts up and executes much quicker. With Node.js, remember that execution is asynchronous. And with Lambda, of course, you can go down two paths. You can have functions that can execute synchronously or asynchronously. In other words, with your asynchronous, they're non-blocking, and with synchronous execution, the function, the Lambda function will wait for its activities to complete before. So it's a blocking design, application design, or code design. Okay, don't assume a function contain a reuse. So in other words, so when the function executes, you can't assume that the next time it executes it's going to be using the same container. Don't forget about the disk. You've got a 500 megabyte temp space provided for each function. Use function aliases. So we provide a number of different ways for you to name your functions. And aliases is a reasonably new feature where it allows you to have, say, for your latest version of your function, you could call it, give it an alias of, say, production, and other newer versions you're working on, an alias of dev, and then in your code or through APIs, use the alias to call your function. You can include the logging service and also create custom metrics in which to determine the way you're going to analyze the success of your function, whether it's performing as you expect or is utilizing the resources it needs, etc., or is executing the right amount of time. Some API gateway best practices. So number one is to use mock integrations with API gateway. So this, again, to test how your code is going to function, not just across API gateway, but also in conjunction with Lambda. Combine with Amazon Kineto for managed and user-based access control. So Kineto is our managed mobile and web identity service that allows you to manage your customer identities and authenticate them with your application, or either web-based or mobile, and combine it with API Gateway to authenticate your users using and calling your APIs. Use stage variables, inject config values into Lambda functions for logging behavior, etc. Use recursive response mapping templates, and also take ownership in your code for your HTTP response codes. In other words, determine what's going to happen with your different response codes, whether they're successful, HTTP 200, or different error states. Make sure you're thinking about how you're handling that from an API gateway perspective. Some more kind of just summing up best practices, and that's to use strategic consumable naming conventions. So in other words, how you name your Lambda functions, your roles, staging names, etc., dev and prod. Using naming conventions and versioning to create automation. So this is again where aliases, as an example, aliases are useful. As you add and create functions, Lambda functions in the Lambda service, the newest version that you've uploaded into Lambda always wins. So if you start with version 1, then you added version 2, by default it'll use version 2. But you can use aliases and other naming conventions to make it easier to call different versions of your Lambda code. Next couple more worth mentioning is least privilege and separate IAM roles. So you want to make sure that you're using the fine-grained access control that AWS gives you through Identity and Access Management, so that your Lambda functions and are just using the least amount of permissions, that you're not giving your customers, your end users, to your serverless application more permissions than they need for it to function. Contact AWS support for large large scaling events. So if you have a new serverless application that leverages, say, Lambda API gateway, and you think it's going to be large scale when you go live with it, don't be afraid to contact support and let us know, and then we can work closely with you to make sure it's going to perform as you need, and also answer any other concerns you may have. Be aware of service throttling, and also engage AWS support if needed. So there you go. That's the webinar. It's kind of summing up serverless, why we see serverless is really important, and kind of a number of examples of what you can use, a combination of Amazon API Gateway, a fully managed RESTful API service, Lambda, our event-driven compute service, and our additional other services, and how you can build complete application architectures on AWS without having to provision or worry about or manage servers. Just a few more things to talk about. So for our lunch and learns, which are occurring over the next 2.5 weeks, we've got lunch and learns coming up with server solutions on AWS, where we're going to dig in much deeper on these services such as AWS Lambda and API Gateway. We're going to do some demos for you, give you some much more detailed information on how to architect and deploy applications on for a serverless. Next week's Auckland Lunch and Learn, we have changed the venue due to popular demand and a number of people coming. We've moved it from to the Crown Plaza Hotel on 128 Albert Street in Auckland. Just know that if you're coming to the Auckland Lunch and Learn next week, you should have an email in your inbox letting you know about the new location, so just have a look on screen as the example. So we've got a lot of time now. We've got about 10 minutes for Q&A on serverless. Like I said, at the Lunch and Learns over the next 2 weeks, we're going to be going much deeper on these services in person, both across Australia and New Zealand. This was just an introduction to core concepts for serverless utilizing AWS and Lambda. Happy to take questions now and provide more information. And I'll just leave it there. And so we've got a question box on the user interface. Feel free to enter in your questions. What questions we don't get to answer over the next 10 minutes or so, we will be summarizing in a document we'll send out to everyone over the next week. There'll also be a copy of this webinar recording available next week. I'm going to look through, just to skim through some of the questions now and see if there's any I can answer I'll quickly answer verbally for those that are interested, is will Lambda ever allow lower memory limits? So at the moment, the smallest resource amount you can assign to a Lambda function is 128 megs of RAM. That is our smallest amount. Obviously, we listen to our customers on what they need. I highly recommend, if you are seeing your Lambda functions and serverless architectures, utilizing much less than that, then I highly recommend using the feedback button inside the AWS console, letting our developer team know that you're using less. For now, though, 128 megabytes is the minimum resource amount you can assign to a Lambda function. Another question there that's come in, what about Golang? So at the moment we support Node.js, Java, and Python. Again, our Lambda team are listening to all of our customers and working. Obviously, we want to make the services most rich and relevant for our customers as possible. So feel free to let our Lambda team know by using the feedback button or contacting support or yelling out to anyone at AWS you know. We're constantly listening to make sure we're innovating with Lambda and adding the features and capabilities you want. So I had an interesting question come in. Would a good metaphor for Lambda be a library? And those functions that the Lambda functions you run, are they equivalent to books? So yeah, well, I don't know if that's a good metaphor. So I mean, I think of just as the interesting thing about Lambda, of course, is Lambda can call Lambda functions can call other Lambda functions. Anything you can most things you can do with the AWS SDK, Lambda can do. So I mean, I would think of Lambda as really the machinery, the computation machinery, the capability for you to have a function of code, and then when you hit the execute button, Lambda is just knowing where to execute it. It's thinking about the complexities of, which availability zone, what is the network it needs, what is the storage it needs, what are all those other kind of bits and pieces. Yeah, I don't know if that's a great metaphor. So another question that's come in is it good practice for Lambda functions to be as small as possible and even store in their own Git repo, or is it no problem to use really large frameworks like loopback.io, etc.? In other words, have really large functions with lots of capability and storing them in the repo. So definitely the smaller, the lighter the Lambda function, the better. The smaller it is, then the quicker it's going to execute. It's going to load and execute, and that saves not only improves the customer experience, but also saves money as well because you're incurring less computation time. I would be, definitely recommend. I mean, utilize libraries inside your code, inside your functions that you need, but keep it absolutely minimal. Yeah, so the next question is this recorded? This session is recorded, and we'll be making it available online next week. So the next question is, I was not able to find any articles describing ways to have dev test environments microservices implemented using Lambda. So Lambda, you write a function and then you assign it a name or a version or an alias. And it's that naming and how you call it that determines the environment and purpose it's going to use. So you can have different functions or the same function executed across different environments. They may be your dev test, maybe your production, and you can utilize the naming of it for the life cycle or the stage, the life cycle of that particular function. But then there's also do you have Lambda functions working across your different individual environments, i.e. your developer environment, production, and test, rather than the life cycle of the function itself. So you could do that as well. I mean, if it's running in VPC, which network or which resources or which applications is that function going to interact with? You may have a function that can interact with different environments that you have for your particular AWS architecture, or you may have an individual function, or you may have different functions. So Lambda functions you only run in dev, Lambda functions you only run in test and staging and prod, etc. So you can determine how you do that either through how you invoke functions or just really the functions you have inside your Lambda environment if you have different functions for different environments or different parts of your application lifecycle. I've got a question here. Can you give us a link for the play on slide? Yeah, we have, and there is also a published case study on LinkedIn as well. So we'll include that in both in the recording and follow after this with URL. So feel free to put in questions into the question box. If you want anything answered, those that we don't get to answer in the next couple of minutes, we will follow up later with questions for. So the next question is, how do we find out whether the infrastructure behind Lambda meets security standards such as PCI DSS? So at the moment, Lambda is not a PCI, one of our PCI services. On our compliance page, we actually list the AWS services which are PCI compliant, PCI approved. Lambda isn't yet one of them. I've had a couple of people point out, really valid, that JAWS is the JAWS framework is now no longer called JAWS, it's now called Serverless. You can get to it at https://github.com/serverless/serverless. So just a correction there. Yes, JAWS is now called Serverless. It's no longer called JAWS. So that's the framework. The Lambda framework is now called Serverless. Thanks, guys.